Okay, let's read the situation. U-Haul is a moving truck rental company. Did you guys know that? No idea. Over 20,000 locations in the U.S. Customers pick up a truck, drive their belongings to their new home. The cost of renting a U-Haul depends on the number of miles you drive in the truck. The table below shows the relationship between the number of miles driven with a U-Haul and the cost of renting the U-Haul. So if we look at that, 10, 15, 25, 40, 50. Okay, question A. What is the average rate of change in the cost of the rental between miles equals 10 or M equals 10 to M equals 25? So M here represents the miles driven. There's a handout. Is there already one on his desk? Okay, so never mind. So when you look at this, this is a very key phrase. Average rate of change. What do you guys think of when you see average rate of change? That's a good one. When you see average rate of change, I want you to think slope. You're looking for the slope of the line, the average rate of change. A lot of times in this class, we will abbreviate that to AROC, average rate of change. Okay? That's a huge deal in pre-cal. So if I'm thinking average rate of change, I'm thinking slope. How do we find slope? It says between M equals 10 and M equals 25. That's essentially means I'm looking at these two values. Those are 2 points with an X and a Y. How can I find slope given 2 points? So close. Y2 minus Y1 over X2 minus X1. Because it's change in Y over change in X. The rise over the run. Right? So you need your Y's on top, X is on bottom. Very important, slope formula. And we're just going to substitute in. So for me, this is my X1 and my Y1. This is my X2 and my Y2. So I'm going to plug in 42, 24 minus Y1, 28, 89 over X2 is 25 minus X1 is 10. And we're just going to plug that right into the handy dandy calculator. As you're doing that, I will tell you that on your AP exam at the end of the year, one of your free response questions will be this. Every time. There will be a find the average rate of change question. In order to get the question, you must do 2 things. You must, number 1, show this formula. So get in the habit of showing this step. Even if you just know you can type it right in your calculator, you need to write it out. Because it has to be shown on the AP test. And then once you guys get the answer, just shout it out. 89 cents. Well, it's a rate of change, so it can't just be cents. That doesn't make sense to just be cents. Per mile. 89 cents per mile, because it's the rise over run, the change in Y, which is cost, over the change in x, which is distance. So the cost per mile. Questions there? Can you do B? Go do B. Find the average rate of change in the cost of a rental between mileage 25 and mile 50. So dumb. I don't understand. What is happening? Okay, that'll work for now. So hopefully you wrote it out. 64.49 minus 42.24 over 50 minus 25, which equaled... Oh my goodness. So the average rate of change between 10 and 25 is the same as the average rate of change between 25 and 50. Meaning, what can we say about the average rate of change? Constant. It's constant. So if the average rate of change is constant, that means it's a constant rate of change. Which means if I have a constant rate of change, it's a line. That's that. If I were to graph all these data points, it would make a line. Constant rates of change equals a line. Average rate of change is constant, so graph is line. Graph is linear. There we go. I'll make it sound a little bit better. Questions there? I also want to point you back to another way we could have found it was linear. This is, again, a big deal in the pre-cal class. It's called equal. Well, let's just talk about what it is first. So I'm going to start by looking at some equal input changes. Here's what I mean by that. Input is x's, right? I changed from 15 to 25. That was going up by 10. So let me write it a little more clearly. That's up 10. I have that same interval happen again here. That's an equal input interval. Both of them go up by 10. Let's look what happens with the y's over that same interval. What happens if I go from 33.34 to 42.24? That's almost $9 more. It's 10 cents short of that, right? So that's up $8.90. If you couldn't do that in your head, how could you find how much you went up? Just subtract them. Right? 42.24 minus 33.34. Now let's do the same thing over this interval. As I go from 55.59 to 64.49. That's almost $9 more. It's 10 cents short of $9 more. Because see that? Over equal input intervals, I get the same change in output. So, equal changes, equal input intervals produce equal changes in output. When this is the case, that means it is a linear function. We talked about a function on Friday. Yeah? What's a function? That's slope-intercept form.
One input has one output.
Semantics. Oh, that's so close to being perfect. Where every input has exactly one output. You can't just say one input has one output, because that just means it has to pass the vertical line test in one spot, not every spot. Every input has exactly one output. Every X has exactly one Y. Hey, you better learn that definition. Hey, it's a very important definition. I might ask you tomorrow or later today. I don't know. It just depends on how this goes. We'll see. We'll see. Question so far on number 1. 2. Graph the points. I don't want to graph the points. I don't have any desire to graph the points. Okay, let's graph the points. I hate graphing. 10 and 2889. That's like here. 15 and 33 something. It's like there. 25 and 42 something. It's like there. 40 and 55 something. It's like there. And 50, 64 something. It's like right there. All right. So, what is that? Oh my goodness. Who would have known? So the second part of the question. What does the graph reveal about the relationship between the number of miles driven and the cost of the rental? So, because points make a line, the cost per mile is constant, which we already saw that. What is the cost per mile? How does it reveal itself in a graph? It's the slope, right? It's the change in y over change in x. This has a constant slope. It has a constant cost per mile. Therefore, it is linear. Three, is the rate of change of the cost increasing, decreasing, or staying constant? It stays constant. Explain it.
It's always 50 ounces.
Okay. That's where we were wanting to go. The rate of change is always 89 cents per mile. Cool. Everybody good so far? I'm gonna have to do a little bit of teaching right there. Let's finish the worksheet up, and then I'm gonna go into some of the pre-cal level thinking. Okay. Right now, it's kind of flirting with the algebra 1-2 land. 4, U-Haul charges all of its customers a minimum base price, regardless of how many miles they drive. What is the base price?
$2.89.
Oh gosh, we're all over the board. What'd you say?
$20.
20. You said $19.99. You said.
Oh, yeah, that's right.
What'd you say before?
I forgot it. I said $8.99.
Gotcha.
Wait, what's right?
I'm just asking. That's what I ask y'all. How could you find what's right?
Because if you can put 10 miles driven times about 89 cents, and it is not $28.89.
So 10 miles driven times 89 cents, because it's 89 cents a mile, right? This would give me $8.90 to drive 10 miles. But I know when I drove 10 miles, they didn't charge me $8.90. Look back at the table. They charged me $28.89. So what I actually paid minus the cost per mile equals the initial cost, which was $19.99. Does that make sense how I got there? Meaning they're charging me $19.99 to rent the U-Haul, and they're going to charge me for every mile I've driven. Okay? How does that show itself on the graph? Yeah. If you think about graphing this line, the y-intercept would be what happens when there's 0 miles driven. So when I just bought it, you see it's just below 20, right? It should probably be right at 20, because 1999 is going to, how are you going to really tell that that's below? You're probably not. So, again, that's just all my human error in graphing. Is everybody okay with that? And then the last one. Give me an equation, C of M, for the cost of renting a U-Haul and driving it M miles.
C of M equals M times 0.89 plus 19.91.
That's it. I'm just taking all the information we've already talked about and putting it in slope-intercept form. Y equals mx plus b. This is my constant rate of change. That's my slope. This was my y-intercept. The cost if I didn't drive anywhere. And I put them in a function notation for driving m miles. Everybody okay with that? That's one. Now, let's talk a little bit more about this right here, and then we'll look at our notes. Okay, where do I want to start? Okay, let's start here. We said this graph has a constant slope. That means we have a constant rate of change. Is everybody okay with that? That seems to be straightforward enough. All right. Next thing I want to talk about is the rate of change of the rate of change. So how much is my rate of change changing by? It's not. It's constant. So the rate of change of the rate of change is 0. So a constant rate of change means the rate of change of the rate of change is 0. You guys okay with that? Okay. And then the last thing I need to talk about is slopes of tangent lines. Oh gosh. I do not think that talking about it from this perspective is the best way to start. So let me go somewhere else to talk about it. You guys know what a tangent line is?
Where is it?
You're thinking of a sine wave. Is that what you're thinking of?
Yeah.
That will be after Christmas. Think geometry class, where you learned about secant lines and tangent lines. Y'all remember what either of those mean?
No.
If I have a secant line of a circle or a tangent line of a circle? Okay, that's fine. So, here's what it means. If I have a circle, and I were to draw a line that touches the circle only once, exactly once, say it's right here. That's called a tangent line to the circle. It's beside it. It only touches it in one spot. Okay? A secant line is a line that goes through the circle twice. So this is tangent. This is secant. Pre-cal is built on lots of thinking of tangent lines. Okay, so let's look at a parabola. That's the most basic form that we can get a good idea of. Is this linear? My parabola? No. So, does it have a constant rate of change? No, it has different rates of change, depending on what points I pick. So, for instance, let's talk about secant rates of change, which is just an average rate of change. To find average rate of change, I'm thinking slope. To find the slope, I need 2 points. So if I picked a point here, and I picked a point here, and I asked for the average rate of change, I'm looking for the rise over run between those 2 points, which would be represented by the slope of this secant line. Because this line touches the parabola twice. So whatever the slope is the average rate of change. Is this average rate of change the same everywhere, though? Think about if I pick 2 different points. What if I pick this point and this point? And I ask you for the average rate of change between those 2 points. It would be the slope of this secant line, which is 0. I tried to pick one that's 0. Right? There was no change, rise over run, from one to the other. That make good sense with this. Now, average rates of change are good, but they can't always tell us what we need, because we like information more quickly, and we like knowing what's happening now. But if you think about this as being a timeline, where x is time, sometimes we don't have all the information yet. And I have to project forward. Or I need to make decisions now about what's happening. Let me give you an example.
What does BLT mean?
Bacon, lettuce, and tomato. Where do you see BLT? Between. B/T. between. Is that better? Thanks. Next time just yell it quicker. Instead of trying to ask everybody what a thing. My handwriting is the best in the world, and you should never question what anything is. No, just ask next time. It is, just ask quicker. If you're asking, you're probably not the only one that doesn't know what it says. Okay. Everybody sit there. Let me give you an example. The difference between an average rate of change and instantaneous rate of change. So, back in the olden days, I don't know if this is true or not. Let's say that you were driving through a city on the interstate. And cops were wanting to find your speed. And here's the way they did that. They picked 2 points on the road. They drew lines. Let's say they were in a helicopter up top. They could see both the lines. Okay? And we saw, let's just make it easy. The speed limit is 60 miles per hour. And these are 1 mile apart. So let's just, does everybody know, how long should it take you to go from one line to the other? 1 minute. Do you know that? 60 miles per hour means you go 1 mile every minute. So it should be 1 minute. So this car drives in here like a crazy person. Okay? It's probably some of you people. I see you drive to school in the mornings. Don't be driving like this guy.
Sure.
Okay? Drives like a crazy person. If they continue driving like a crazy person all the way through, is it going to take them under a minute to get there? Yes, because they were speeding when they entered. They sped the whole way. At every point they were speeding. But what if this person was sharp? And they knew how this worked. And they were driving in here at 100 miles an hour. And they said, oh no, I see the helicopter. And they slowed down to go about 20 miles per hour the rest of the way. And by the time they finished, it took them 1 minute and 20 seconds to get through that whole time. For their average rate of change between this point and this point, were they speeding? They weren't. From here to here, it took them more than 1 minute. So they weren't speeding by the way we were measuring it. But were they speeding? Yeah. So how could I catch them? If you're the cops, what could I do to catch them? I need to get a better system. Which would be what? How can I make this better? We're getting there. That's where we're going. I don't have this is the olden days before radar guns.
Make it smaller.
Make what smaller?
The line, the distance.
Change the interval. So that they're not 1 mile apart, they are
Half
1/10 of a mile. 1/4 of a mile. As I shrink the distance and I get these points closer and closer together, I'm going to get a more accurate reading of their actual speed at that moment instead of the average speed over 2 points. That makes sense? The closer I can get those intervals together, the more exact I can get. So what I'm essentially looking for, take it back here, these are 2 points that are far apart. To find a more accurate reading of what the actual rate of change is at any given point, is I need to shrink the distance between the points. And get the points to be like from here to here. And find the secant line through there. And what we're doing is, we're taking that secant line through 2 points, and we're eventually getting them so close that it's essentially a tangent line. A tangent line is basically just using 1 point instead of 2. But I'm getting the points so close together that it's basically 1 point. This is called an instantaneous. I can't spell it. Instantaneous rate of change. Using 1 point instead of 2. Because how do you find the average rate of change? Slope formula. You need 2 points. y2 minus y1 over x2 minus x1. I don't have 2 points. I just want to know it from 1 point. To get the points as close as possible. Does that make sense, what I'm explaining? So, so many places I can go from here. Radar gun. How does a radar gun work?
How fast the laser can go out and come back.
Close. Yes, there's a laser being shot out of a car, but it's not just one.
Many.
Two.
It's two, and then they subtract.
It's two. You're correct. The radar gun does the slope formula for them. It sends out 2 beams of light as fast as possible, consecutively, to get 2 points, where the interval is shrunk as close as possible. And then it calculates the little distance you traveled in that little microsecond of a second. And then they can calculate your speed. So it's essentially your instantaneous rate of speed. Because those 2 points were so close together that the radar sent out its beams. Does that make? So they are doing this shrunk down on a small scale in a gun that does all the math for them. So, moving on. Did I talk about the difference between the names? This is a secant line between 2 points. This is a tangent line, which is 1 point. Think about what happens if my original graph is not a parabola, but the original graph is a line. What would happen if I made a secant line on this line? Secant lines need 2 points on the line. So if I picked a point here and here, and I connected them,
This is still on the line.
But they just got through
It'll
it
be
with
multiple.
your parabola.
yeah, no matter what 2 points I pick on this line, the secant line is the exact same as this line. Because it's a constant rate of change. So, the note that I needed to tell you, but I had to go on a big tangent to explain it to you. So thanks. Thank you. I'll be here all week. This is the slope of the original line is equal to the slope of secant lines and so I didn't do a good enough job here. Can you, in your mind, make tangent lines to the parabola? So if I just gave you 1 point here, could you draw the tangent line from that point? Tangent line means it can only touch it once. I don't have a good way of teaching this, other than most people can just think we're good. We can do that. So, think about drawing a tangent line on this graph. See, this is not a good graph for it, right? It's a lot easier on a parabola. But this is why I don't like this as my first example. That's why I'm going somewhere. The tangent line is the same as the secant line, is the same as the original line. Because what am I measuring with all of these lines? I'm measuring rates of change. Either the average over 2 points or the instantaneous over a single point. But this had a constant rate of change, meaning the secant line and the tangent line are all the same line everywhere. So the slope of the original line equals the slope of secant lines, which equals the slope of tangent lines, everywhere. So I need to talk about tangent lines and secant lines. So when I tie that together initially, I want you to think about geometry class. Don't think trig, think geometry. Especially with a circle. You had trig in your algebra 2. You did sine, cosine. You did. You had sine, cosine, and tangent built into some of your algebra 2 stuff. Probably. Thank you. So, I don't want you to think about that kind of tangent. I want you to think about circle geometry tangent. Circle geometry secant. Does anybody remember the definition of secant lines?
It's a circle and a line that makes an arc or something.
Okay, you're in the right ballpark. So if a line touches a circle at one point along the outside, this is called a tangent line. You don't have to. If you'll just go on this math journey with me, you'll be okay. You need to write down the big ending. But the math journey, I'd rather you be focused in on me instead of... people learn differently. I definitely wouldn't write this down. But that's... Thanks for saying I have a big head. So from here, this line goes through the circle in two places. This is a secant line. Okay? Secant lines versus tangent lines. Is okay with that? We're going to move this over talking about it with functions. Forget circles with functions. I'm going to specifically talk about a parabola because it gets very confusing when you talk about it with a line. And we're in lines right now. So I need to tie this back to... No, I need to tie this back to parabolas. No questions right now. This is story time. So... If I pick 2 points on the parabola and I draw a secant line between them, this is, think about that line. That line has slope, right? It has rise over run. The average rate of change is the slope of that line. So for a parabola, if I pick any 2 points on the parabola, are they all going to have the same slope? No. The same average rate of change? No. Like if I pick this point and this point, it would have a much different slope than the first one. Right? Okay. Yeah. Everybody's good with that? Yes. Secant lines. 2 points. What we are wanting to do is average rates of change like these are good. They tell a story over a specific time. Think about this as like a timeline. I'm going left to right. So the X's are time. This tells a story about something that happened over that time. But we would like to be able to find slopes without having to have 2 points. Because sometimes you can't have 2 points. Because you may be too close to the data. It could be being formed as it's happening. And we need to know more. At one point, what would the slope be? Okay? And so the slope at one point is a tangent line versus a secant line. So if I picked at any point in time here, and I ask, what's the slope here? Just imagine drawing a tangent line to the graph at that point. That tangent line, whatever the slope of that tangent line is the slope of the parabola at this point in time, instead of over an interval of time, like there was before. Okay? We are not, in this class, we are not going to learn the math behind how to find the slope of this tangent line. We just need to know, for looking at the graph, can you draw a tangent line and then compare it to other tangent lines. So for instance, if I were to pick this point here, could you draw a tangent line to that point being right there? Right, it's slightly negative at that point. If it was right at the very bottom of the parabola, it would be 0, the slope of that tangent line. Okay? Does that make decent enough sense? All right, the next thing I want to talk about is like a practical use of this. So, I'll go quick. Think about why this is important. Why do average rates of change not always work for us? Well, we're not always going to have nice shapes like parabolas. We could eventually have some graphs that are really strange. And if I tried to find what's the average rate of change from this point to this point, it's 0, but that doesn't do a good job of telling me the story of what happened, right, along that graph. So I need to shorten my timeline. I need to get more specific with my interval. So here's my story. Here's the way I'm going to explain it. Think about you are a police officer trying to stop people from speeding, okay? And you've got set up on the interstate. That sounds like that was too personal for some of you. You've got set up on the interstate 2 mile markers. Say these are 1 mile apart. And you've drawn a line on the road between them. And let's just say, for the sake of argument, that the speed limit on this section of road is 60 miles an hour. So if these are 1 mile apart, how long should it take you? What is going on? How long should it take you to travel 1 mile of a speed limit at 60 miles an hour?
An hour?
You can go 60 miles in 1 hour. I mean, you go 1 mile a minute. A mile apart, it should take you 1 minute to travel this distance. All right? So say one of you, somebody, comes flying in here at 100 miles per hour and then says, "Oh no, I'm in trouble." And they slow down and drive 20 miles per hour the rest of the way, for it to then take them 1 minute and 20 seconds to get across that second line. The person who is measuring with a stopwatch, did it take them 1 minute to get from here to here? It did. So from the big overview, were they speeding? From here to here, they weren't. So you, being the great officer of the law, what can you do to better catch speeders in the future? You need to come up with a better game plan, because these people are outsmarting you.
Watch them directly.
The guy pulled me over had a radar.
Radar gun, that's nice. That seems like a much better idea, right? You know how a radar gun works?
Radar signals.
I'll explain in a second. But say we didn't have a radar gun. We're in the process of getting there. What could you do to catch the speeder? Shorten the distance between them. Get my interval of time much closer together. Instead of being a mile, what if I measured every 1/10 of a mile and then did the math between them? Or then if they still cheated, what if I went to every 100th of a mile? And could get smaller and smaller intervals of time until my 2 points were almost the exact same. They were so close together that I get what's essentially an instantaneous rate of change instead of a average rate of change. You see the difference between those. Radar guns, how they work. We've got 1 minute. Did you know radar guns, they send out 2 beams of light. Two radar signals that are sent that quick apart. And then they measure how long it takes them to come back to the car. And then they calculate the slope from those 2 points to find your average rate of change over a millisecond. Which is essentially, the radar gun does all that behind the scenes. Essentially, the radar gun does an instantaneous rate of change, which was done over a mile here, to a very small amount of time. Almost instantaneous.
Homework tonight.
Huh? It doesn't. So the radar gun knows how fast the beams of light were sent. Say it's 0.01 seconds. So that's your change in X. All it needs to do is figure out the change in distance. So it knows how long it takes for that radar beam to come back. It can figure out the distance it traveled based on the time it takes for it to hit your car and bounce back. And then the second one does it. And so it has two distances. The subtraction shows the distance you traveled over time. Let's see, distance over time, rate of change. That's where I was supposed to be getting to. Yes. That's why it's weird. That's why I explained it with a parabola to that. Our secant line would actually just be the line. And our tangent line would just be that line. They're all equal. I didn't get to that point because I ran out of time. But that's where I was headed. Check your understandings.
That was the boy that used to go to the evening.
And the problem.
Oh my gosh!
I was freaking out. She's like, "Oh my God, you're freaking
None of that. I'll tell you when we start doing this. None of that has became you. The 17th.
It was so
Okay. September 17th is our next test.
Really? A day before my birthday?
I'm so sorry. My apologies.
Because I was like, I know y'all, your siblings off, and she was like, yeah, that's all of them. And I was like, bro, no way. I was like, I drove my house house before.
That's so cool.
It was, I was like, it's connected.
Bro, one of our
That's fine.
Or one of our old ones.
Everyone's connected.
That's good.
Everybody.
Cheer.
That's so weird.
Maybe.
Who?
We'll go to the second.
They moved, but
I'm spinning it all on my.
I remember playing one of them. They used to play with everybody.
Why are you sitting over here? Oh, and then you did?
That's why you got that game.
I don't know who's scribbling.
I'll look at
Look at me. Look at me. 13? That's what it is. Oh, we should have done.
I just said it.
I fell asleep reading.
I did that when we finished trying out with the one. I fell asleep with that whole book.
She fell asleep off chapters. So that's what he's low.
I'm sure actually books.
Let's see if Stacy will read those today. Well, I didn't know they would all do it at 9 o'clock, so I got my homework at like 9:20.
Everything stayed that time.
Yeah, I thought it'd be 12.
What class?
Sign.
I've done everything. I need to butter my work. She's there. She won't bring up my quiz yet. We have Jen Sloss. Come on.
Oh yeah, he's running first.
Yeah. Actually,
I was gonna run through it, but it's like a club. You know. Yeah, but that and you have to do a lot of stuff throughout campus.
Is this part like all
open my test.
this? Which you can understand
What's
yourself?
Spanish?
Maybe I can do it.
Frankie, give me your phone.
Just explain this, that if you want to know how to do like the edit stuff.
Maybe you should just like done work instead of like lessons.
What if I'm just gonna sit there and sleep the whole time?
Then I guess don't.
I need to find out her boyfriend's last name because
It's
I do
like,
not remember this man,
it's
but
like
he remembers
Schwab
me.
or something. It's not
He
weird.
really,
What's
So,
Aubrey's boyfriend's last name? Slaughter.
apparently he used to live beside me and we used to be like best friends.
Do you remember?
I remember playing with a few people, but I don't remember him.
Yeah.
But like, he knows my name and he knows me and he knows all my siblings and he knows where I live. Like,
So why does she have
But
to
he's
whisper?
also a little bit older than you. He's about,
that is, yeah.
I think he's about to be 18.
That's
18.
Okay.
So he was at least
Pretty sure he
probably,
is 18.
I think he might be 17 or he just turned 18.
Yeah, but also to do with.
So that means he had a better, he couldn't remember all of that.
Yeah.
So that's probably why he knows all of it. You probably was just a little,
Little child.
little child. He had more of a,
Yeah.
I'm going to go.
I need to decide that.
Sure. Good.
No,
Bro, I got freaking chocolate on me.
because next summer.
That works.
Wait, we got strawberries
Yeah.
for, I didn't
Might need
think,
a
I was
ring.
gonna turn up. No, I didn't. I was gonna, but I couldn't know.
I was at work and there was interview interviews. And I was like, there's this Hispanic kid who showed up and he was so awkward. And I felt so bad for him.
Yeah, give me the job.
Because they asked him if he wanted coffee and he was like, sure. I was like, why?
Well, you're a cook, so you should.
Well, my hair doesn't fall out.
What do you have to wear? Do you have
I
to-
can't.
Gloves.
That's it? You don't have a uniform?
No.
An apron?
I need to wear my apron.
Obviously, what's
Because
your outfit?
my shirt's literally covered in grease.
I thought you were in a coffee shop.
I do.
He's a
In
cook.
the kitchen. Yeah, breakfast and lunch.
He like makes like bacon and sausage and stuff. He's gotta get Christmas. And burns himself, obviously.
That's my second part.
Literally cooked yourself. For what reason? That's disgraceful. Where I burn myself.
Oh my gosh.
Yeah,
I wasn't even touching anything hard. I just rubbed it against.
bro, look. Look at my wrist.
Why are you cutting your toe?
I know you're lying. No, I'm having an allergic reaction to one of my bracelets. So my mom banned me from wearing bracelets. I now have to wear them all one at a time to figure out which one I'm allergic to because I can't wear like nickels in my ears either.
That's not.
Or my earring holes are like close up.
Yeah.
It's disgusting.
Another
But apparently I'm allergic. not
Why
to
is,
ears.
why is?
Hey,
why
Frank.
is he doing
Hey, Frank.
that? That is so
Hey,
weird.
Frank.
Hey, you should bring me a dog.
They're out.
Sorry.
Of course we're out.
Sorry. I'll tell her to buy some more for you.
Don't lie.
I've been good.
I'm not.
Don't lie. You probably drank it all.
I'll tell her to buy some more for you, or I'll go to the store later and buy them.
Wow, you're so kind.
Annabelle must have probably beat her this weekend. Like he needs. I haven't seen Carter in like 5 days because he's just been sick. Again.
I think 4 physics classes.
I know that.
Yeah, I'm not
Who? For what?
at Northeast if I get
You also take 4
physics classes.
What chemistries will you take?
111, 112.
Oh, that's okay.
Yeah, that's not bad. That's bad. That's
Not me.
Yeah, that's good. The worst I'll have to take is microbiology
Jump off
and
the top.
the concentration on math is like either 3 or 4 classes.
Here there's 3 ads. And then there's like, some physics. Okay.
Yes.
Good luck.
I'm just gonna.
Have fun with that. Kuda said calculus isn't that bad though.
Well, math, anything math in general is not that bad, so.
I can actually just instead of doing the
Bro, look at
entire
my red
science-
up. Stop playing on me.
Oh, very cool.
I got a few little trade day thing going on this week.
Are you married?
Yeah.
Not to a cat. It's
It
a
literally
cat.
said cat on
She
it.
wasn't
I
there.
love it so much. It's my
I don't know
favorite.
what medicine looks like.
I forgot to show Annabelle. Nothing.
The environmental science was so
Tell Annabelle.
Oh, I'm still recording.